today's session, we are going to start with the all new chapter of dyes and its intermediates. So, let's just understand first what do we mean by the dye and colors. So, as you can see here on the screen that dyes and dyes are basically colored organic compounds that are used to impart color to the various substances, right? So basically these are the one kind of a substance or the compound that are being used to impart or to implement color on any substance, right? This substance can be anything. It can be cloth, it can be polymer, plastic, it even can be a wall, or it can be anything, right? So basically this includes paper, leather, fruits, drugs, cosmetics, wax, plastics, grass, and even some textile materials. So all this substance can be colored with the help of dyes. So basically dyes are the compounds which are being used to impart or to implement color on the different components or the substance. Now the pigments are the material. They can change color of reflected or the transmitted light, right? As the result, wavelength of the selectively absorbed. So basically these pigments are being used to change the color of reflected or the transmitted light towards the substance, right? Which means this pigment absorbs some specific type of the selected wavelength by which they can reflect or transmit different colors of light. Then dyes are basically normally water solubles or the water dispersible organic compounds, right? So basically dyes are generally referred as the water soluble compounds. While the pigment, both organic and the inorganic types, are almost applied in aggregated or the crystalline insoluble form. They require a binder to form a coating on the surface of a substance. So basically these pigments are generally not water soluble compounds. They require one more medium that we call as the solvent or the thinner. So based on application of this pigment, we are selecting solvent or the thinner and we are imparting color on the different substance. So now let's just understand the classification of the dyes based on their application. This question is again very important for the exam point of view. So the first class is the acidic dyes. As you can make out from its name that these dyes are basically acidic in nature and they are sometimes also being called as the anionic dyes. These are the water soluble dyes having sodium salt of acidic group such as SO3H or the phenolic group, that is OH negative. They have affinity for the protein fibers like wool, silk and leathers. So these types of the dyes are used to dye the animal as well as synthetic fibers. So basically these dyes are more affiliated towards the wools or the silk kind of fabrics. Hence they are being generally used to color up our different fabric that are being obtained from the animal skin or they are being synthetically produced. Now if we look at the next point, then they are used to some extent for the paper, leather, inkjet printing or even some food and cosmetic appliances as well. So these kind of the dyes are also being generally used for different purposes as well. They can also be used on the paper, inkjet or food and cosmetic industries as well. Now this dye can be removed from fiber by washing. So with the help of washing, we can even remove this type of the dye imparted on the fibers. And this is the one example of the dye, that is acid yellow 36. As you can see here, it has 3 benzene ring. Both every benzene ring is being interconnected with the NH, that is your amine. And at the last we have acid group as well, that is SO3H. So this was all about the acidic dyes. Now let's move to the basic dyes, and you can see here these dyes are again very much water soluble and they are mainly consist of amino and the substituent amino derivatives. So in this particular dye we will have amino group as the main functional group, right? Even some amino derivatives are again also be imparted on the benzene. We will understand them with the help of example as well. So this amino group are again be protonated under the acidic condition, and salt linkage is made between acidic group of the fiber and amino group of the dye. They are generally give the intense and bright shade but poor light fastening properties. So as you can see here, they are being generally used for the intense and bright shade of the light, but they are give very poor fastness of the light, right? They are being used to dye paper, then polyacrylonitrile and modified nylons, and even sometimes modified polyester as well. So they are can generally be used for the different application as well. As you can see here, this is the structure of the crystal violet, which is one type of the basic dye, in which you can see here we have one amine group which can link with another different groups, right? And one fluorine negative group is also being there. Now, if we move further to the azoic dye, then this type of the dyes is being manufactured inside the textile mills fiber by Azo company. A variety of hues can be achieved by the proper choice of a diazo and coupling compound. So these are the mainly. So this is the largest group of the dyes. The azo dyes are being prepared by selecting different azo group and different coupler groups, right? We can found number of combination of such dyes, right? Different azo group can also be linked with the different types uh, of the uh, couplers, right? Then these dyes are treated with the soap and resin to produce insoluble azo dyes. Mainly it is applicable in the cellulose fiber, especially cottons, and it gives very high standard shade and fastening light to wet processes. So they are being generally used to impart color on the cellulose fibers, and they give very high standard state, right? Generally they are being used to give color to the cotton based fabrics. They give very bright and intense, particularly yellow, orange and red shade. So to give yellow, orange and red shade, this kind of the dyes are being largely used at an industrial level. They contain an azo group, that is your end bond end, which referred as the chromophone in between two organic rings. So azo group act as the chromophones between two organic rings. As you can see here, we have different organic groups. We have different organic groups, which represented by these benzene rings, particularly naphthalenes, which are being interconnected with the azo amino group, that is your N double bond N group. As you can see here, this is one interlink, this is another interlink, right? This is the specific example of the Congo red, which covers under the dye of azo dyes. Now, after discussing azo dye, let's just quickly move to the direct dyes as well. So, as you can see here, this direct dye are basically water soluble dye, right? And they are having one group which is your sulfonic acid. So, there will be always one sulfonic group with the acidic dyes. However, these dyes are not considered as the acid dyes because these groups are not used to attach to the fibers. So, these kind of the dyes are generally not considered under the tag of the acidic dye, since they have the sulfonic acid group as well. Because these dyes are not being used to impart color on the fabric materials. This is why these dyes are not categorized under the acidic dye. These direct dyes are very large, flat and linear molecules which can water soil and amorphous of cellulose and orient themselves along the crystalline regions. So these dyes are generally very large and linear. These dyes are generally having very large and linear molecules. Hence, the common salt or the gobar salt is often used to promote dyeing, and hence this process is being also called as the salt dye. So now, after discussing direct dye, let's just move to the reactive dye as well. As you can see here, this dyes is the class of one. This dyes is one of the. So as you can see here, these dyes are the class of dye which forms covalent bond with the fibers, and it also contains amino or the hydroxy groups. So these reactive dyes are generally forming one covalent bond with the fibers, and they have amino and the hydroxyl group within it. The reactive dyes are the molecule consist of dye attached to a fiber which are being reacting systems. These are mainly used for the cotton and the cellulose fibers. So these dyes are find their application for the cotton and the cellulose type of the fiber materials. These reactive dyes can be derived from the azo, anthraquinone and phthalocyanine dyes, which now conclude the classification of the dyes, right, based on their applications. Now let's just move to the next type of the classification of the acidic of the dyes, and this is the classification of dyes based on their structure. So now based on dye structure, we can also even define or the classify different dyes. As you can see here, the first classification is under the tag of nitro or nitroso dyes. So as you can easily make out from the name itself, this group of the dyes also contain nitro group as their main functional. They are nitro or the nitrous group as the chromophore and hydroxyl group as the exochrome. These are the further classified into the two parts. One is the acid dyes and another one is the dispersed dyes. So these dyes can also be categorized on their application as the acidic dyes that we have understood in the previous classification. Now acid dyes has the solubilizing groups such as sulfonic acids. So this is one more example of the nitro group, right? Nitro dyes. As you can see here, acid yellow 36 which contains nitro group as the linkage. So these dyes can also be referred as the acidic dyes because it also contains acidic group here as well. Now after this nitro dyes, there is one azo dye which contains azo group, that is N double bond N. This group acts as the chromophore in between two organic rings. This chromophore refers the group which is being responsible for the linkage between two aromatic rings. Now these azo dyes form the largest group among the all synthetic dyes and give wide variety of the colors. So as I have described already that azo dyes are being largely used for the industrial purpose, and we can produce different types of the colors and different types of the dye based on their azo group and their coupler, right? There are a number of possibilities to generate different colors by means of these azo dyes. They are further classified according to the number of azo group present in their molecular structure. They can be defined as monoazo, diazo, triazo, and so on. These are directly applied on the fiber, usually cotton, rayon, and the polyester. So cotton, polyester, and rayon are generally being used for the application or for the imparting the color on this material. So that this concludes the azo dyes, and this is the particular example of one of the azo dyes, right? Now after discussing this, let's just move to the indigo dyes and let's understand what do we mean by the indigo dyes. Again, these dyes are very important and their classification is very important for the 7 marks in your GTU exams. This is one of the very oldest dye having indigo group as the chromophore. So these are the very oldest form of the dyes, right? We are using such dyes from the ancient time for the different applications. It used extensively due to special and very good fastening properties. So these kind of the dyes are being largely used because of their good properties. They are important weight dyes and it is being used for the dyeing of cotton, wool and polyester as well. So these are the one class of the wet dyes which are being used to impart color on the polyester, then the cottons, and this type of the dyes are very much water insoluble and cannot be used as a directly for dye. So these dyes cannot be used directly for the dyeing purpose. Hence we have to further process them with one kind of the applications. And they are again water insoluble. On the reduction in the presence of alkali, they become water soluble. Hence we require one alkali medium so that we can impart these dyes on any particular substance. And they acquire affinity for the cellulose fiber. So in order to impart color on the cellulose fiber, this type of the dye is initially dissolved in some alkali group and later they are being imparted on the cellulose fibers. So this is the structure of indigo dyes, right? Now after referring this indigo dyes, let's just move to the next and last classification of the dyes, and that is cyanine dyes. So as you can see here, these contain two quinoline rings attached through methane or the polymethane. So as you can see here, they contains two quinoline rings attached through the methane or the polymethane, right? These attributes has led us to the development of different biological applications that include DNA sequencing, then immune assays, then fluorescent microscopy and single molecular detection. They are also being used as the photography sensitizer, right? So as you can see here, this is the structure of the cyanogen dyes. So after saying that, this concludes the today's lecture and all the classification of the dyes. In this video, we have understood what we mean by the dyes and pigments. And we have also classified dyes based on their application in number of dyes. And we have also classified our dyes based on their functional group or the structure. So now in the next video, we will understand how we can manufacture different dyes. And we will also understand what do we mean by the varnishes and different pigments. Till then, keep watching, keep learning. Thank you.